Okay, this is refraction. Refraction is the bending of light waves as light moves from one medium to another. So recall that medium just means some substance, some material. And let's come down here real quick. So these are examples of materials that light would travel through when we're talking about refraction. A vacuum just means empty space. So like outer space where there's no material whatsoever, light will travel through it. Air, light travels through air, can travel through water, ice, quartz, crown glass, flint glass, zircon, diamond, translucent materials. And what refraction is that when light waves goes through from one material to another material, it will bend or change directions. And so here I have air as an example. Light is traveling through air, and over here is water. Okay. When light comes in, you would think that it would go, okay, let's make this a straight line, pretty close. Um, the light you would think just keeps going straight like this, but when it goes from one material to another, it will change directions. And we can use angles to show that change in direction. So here's the light coming in. If we drew a dotted line going straight up here, we would measure an angle between the ray of light and this dotted line here, the normal line, to be theta 1. And down here, if the light bends like this, we can measure this angle would be theta 2, which is different than theta 1. And the mathematical relationship between, to help us predict what this new angle is going to be is what we call Snell's law. So that's kind of the title here, Snell's law, which is this equation right here. N1 sine theta 1 equals N2 sine theta 2. Theta 1 and theta 2 are those angles, and N1 and N2 is what we call the index of refraction. It's a number that's associated with the material that the light is traveling through. So air has a value of 1 and water has a value of 1.33. And so yeah, we're going to use this equation. For a moment, I want you to just think of this equation as A times B, so some number times some other number equals, you know, C, which is this number, times D. Let's do that. Just think of it as four numbers, okay? Try not to be distracted by the sign. The calculator does the heavy lifting for that. And just real quick, the index of refraction, that number that we're referring to here, is simply a ratio between the speed of light in a vacuum divided by the speed of light in that particular material, in that particular medium. So when light travels in a vacuum, it goes the speed of light. When light travels through water, it goes through some speed that it slows down. It travels with a speed that is less than the speed of light in a vacuum. So all these materials here, speed of light is less. And so it's simply just that ratio, C over V. So let's just right ahead jump into an example. A ray of light travels from air to ice. And so right away, we need to know what the index of refraction for air is. That's 1.0. And we need to know what the index of refraction for ice is. And that's why I put this little table here. Ice is 1.31. So kind of squeeze that in there. The angle of incidence, okay, fancy word for just saying theta 1. The angle of incident, that means that the light is incident, is 32 degrees. What is the angle of refraction? So Snell's law lets us predict what that refracted angle is. N2 sine theta 2. So let's put in some numbers. I want you to think of it like this. The left side is what's going on in the air, is the first material. It's the incident rays in that material. So N1 is the index of refraction for air, which is 1. We'll put sine. Theta 1 is the angle of incidence, 32. N2 is going to be this other material, ice, which is 1.31. And then we have sine theta 2. We don't know theta 2. We're trying to figure that out. Again, just think of this as A times B equals C times D. These are just four different numbers, let's say. So how do we isolate this number here? We're going to divide both sides by the 1.33, 1.31, excuse me. Cool. That cancels there. I wouldn't type this in the calculator just yet. We have 1. Yeah, we have 1 times the sine of 32 over 1.31 equals sine of theta 2. Now, now we're going to deviate. We're not going to think of this as just one number. I mean, it is, but we need to get rid of the sine. We want it to say theta 2 equals something, right? Some number. To get rid of a sine, we're going to use arc sine or sine inverse. So that's sine to the -1 or sine -1 of all of this. And we do the same thing to this side, sine -1 of all of this. Well, that cancels that sine here. And all of this we can just type right in the calculator. Sine inverse of this fraction, 1 times sine 32 over 1.31. So let's grab the calculator. Let's clear everything here. Now, sine -1 is blue, so I had to hit second. Let's put a fraction in there. Let's put 1 sine 32, I believe it was, and this is 1.31. Cool. Real quick, you have to make sure you're in degree mode. So not radians, but degrees, which we are. And so I'll just double check. This is 23.86 degrees. Probably overkill. We can say 24 degrees. It's fine. It's supposed to be a degree symbol. 23.86. So just real quick, well, we can do better than that. If I were to draw a picture of this, which you don't have to, we do this. And here's the light. Let's make it blue. Now we are showing that this angle is 32 degrees. And so we don't want 32 degrees here. It's actually going to be less. And this angle is 20, let's call it 24 degrees. So it bends a little bit. This angle is less than this angle. That's all we're saying. That's it. Cool. Let's see. So I'll give you a point for having Snell's law, n1 sine theta 1, just exactly the way it's written here. I give you a point for that. I give you a point for substituting in your numbers correctly. Like this has to be the index of refraction for air, and that needs to be the incident angle. You can't have 1.31 here in the 32. That would be wrong. So I'll give you a point for having those correct numbers in there. I'll give you a point for using sine -1 because that's crucial. You have to use that. And oh, I don't know. What else? What else? Yeah, I'll give you a point here for the correct answer. So that would be like 4 points. Okay, it's supposed to be degrees. I don't know if I'm going to be checking for degrees, but make sure you have the degree symbol. I may or may not give a point for that. Who knows? Cool. What is the index of refraction for amber if light travels through amber at a speed of 1.93 times 10 to the 8 meters per second? So this is n equals c over v. N is what we're solving for. C is the speed of light in a vacuum. This is 3 times 10 to the 8 meters per second. So this is 3 times 10 to the 8 meters per second. Is C always this number? And yes, the answer is yes. It's a little bit rounded up, but that's fine. So you can always count on C to put in this, you can always count on this number to put in for C. V is the speed of light in that medium, which is amber. So in this case, so we'll put 10 to the 8 here. Cool, and we'll just divide those. Dun, 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 dun. I just need a fraction. 3 times 10 to the 8. And I've already forgotten what that other number is. 1.93 times 10 to the 8. Cool. The index of refraction is 1.55. There are no units because the units cancel. Oops. And by the way, that's how we figure out these numbers here. It's a calculation done that way. That's one way to figure it out. Cool. Yeah, just remember that C, whenever you're using this equation, you can always count on that number for C. Cool. What is the speed of light as it travels in water? Well, we can use this as well, but we're looking in this case for V. V is I have it all over here. V is the speed of light in that particular material. C is always 3 times 10 to the 8. So we are looking for V this time. So before we solve for V, let's isolate V, divide and multiply both sides by V. This one cancels. This is V times N equals C. Well, let's get N out of there. Divide both sides by N. So V is just C over N. So V is 3 times 10 to the 8 over N for water. The index of refraction for water is 1.33. Cool. Let's calculate it. Fraction 3 times 10 to the 8 over 1.33. Okay, let's talk about this. This says 2.25. All these digits don't really matter that much, but what matters though is the E8. E8 means times 10 to the 8. It's showing us just the exponent. This is scientific notation. So let's say 2.26 times 10 to the 8. Or if you wrote 2.26 E8, that also works. Meters per second. I think I like this notation. I'm going to try to get used to just writing it like this. Okay. Oops. There we go. I think that's it for this lesson. Okay, just real quick about your homework. Your homework, you're always going to be solving for the angle of refraction, or you're going to be solving for the index of refraction n. So you're going to use like the first one or the second one, I think, for the most part. That's it.